this quiz preview will be online later, so if there's parts that we're looking at and you're like, yeah, now how's that work again? We'll make sure. Okay, so number 3. What we're going to do here is, remember, and we talked a little bit about, I'm going to treat this absolute value as though it's x, that I'm trying to isolate this of itself. So I'm like, okay, so I'd have to minus the 8 out of there. So once I get there, now what I've got to do is I've got to say, okay, I'm going to split this up into 2. And remember, when I do the second one, I'm changing the sign on my solution. So once I get here, now I'm just solving them like I would a regular 2-step equation. I'm going to add 7 to the other side and divide by 2. Okay, and that's where my 8 would come from. And then here I've just got to be careful, because when I'm adding 7 to my negative, if I owe somebody $9, now I'm paying them 7 back. Now I only owe them 2.
Okay, I got it now.
Yeah, sometimes you can do all the big stuff right, and then it's just some little thing that will end up nabbing you at the end. But yeah, every time on those with the absolute values, you've got to have the absolute value alone first before you go splitting them up. Otherwise, it might run you into a dilemma. Which one? Okay. Let's bump up a little bit here. All right, so solve by showing work, graph the solution, state the solution in interval notation. Okay, a couple of things here at the start. Got to understand what the arrow means, because that tells me a lot of information before I ever start. Is this an or or an and? And. If the absolute value, if my arrow is pointing at it, if it's less than, okay, that's going to be an and. And that's important, because typically ands, if I remember right, are going to be something that kind of looks like this. Basically, they come together in the middle. So I look at this and I go, okay, now how's this go again? And there's a couple of ways that you can do it, but for the way that we've done it for the most part, and that's the way I'm going to do it here, copy it the first time. Second time, copy what's inside the bars. Notice I didn't change anything inside. Okay, I didn't change this to positive 4x. Nothing with that. Switch the arrow. Switch the sign. That never changes. Arrow and the sign of your answer, air quotes. And then I just solve each of these. So let's see here. Minus the 12 over. Then we run into our first dilemma. When I divide by negative 4, if I multiply or divide both sides by a negative, yep, we got to switch the arrow around. And if you want to on this, if you want to go to a decimal, you can. If you want to go to 3 halves, you can. If you want to go to 1 1/2, you can. I'm fine with any of them. I understand when you're graphing, it might be easier to see the decimal. So then I look at the other one. I'm like, okay, same deal going on. Minus my 12. And these are the little things that I've noticed on quizzes and even the homework so far. It's being careful on stuff like this and not like minusing the 12 and calling this positive 6. I'm like, be careful. Again, we're dividing by a negative, which means we have to flip the arrow. And again, as a reduced fraction, this would be 9 over 2, otherwise known as 4.5 or 4 1/2. So once I get here, I have a pretty good idea of what this should all look like. And hopefully it works out for me that way. And I'm fortunate I can count by 1 1/2 everyone. If you counted in whole numbers and have to have your brackets in the middle of, spaces here, that's okay too. So let's see if this worked. X is greater than or equal to, arrows eating x, greater than or equal to 1.5, which means it's going to the right. I'm like, okay, that's okay. Then x is also less than or equal to 4.5, which means we're going to the left. Hey, nice. Okay. They're going to come together in the middle, which is what I thought they would. And then my interval notation, like it has been all along, we just work left to right. Left, I'm at 1.5. Oop, I do have a stopping point here at 4.5. And I'm good. But again, the proof is going to be in your attention to detail. Do you remember to flip your arrow and your sign, or do you just do one? Okay, I saw that a lot when we were doing the homework check. I'd see the sign get changed, but the arrow wouldn't flip. And then all your graphs are going the same direction. That's something why, if you know what and or should look like, that should be a caution flag. You should go back and say, wait a minute, what's going on here? Because some of you are just leaving it going, okay. And we can't do that, because that's when issues come up on the quizzes. But also, and I'll just say one other thing with inequalities while we're here, and then we'll do more questions that you've got. Remind yourself, and I do this on purpose, when you're doing number 1, there's no absolute value anywhere. So I'm not doing 2 on that one. The only time I do 2 is when I've got the absolute value bars. So if I were to throw one in tomorrow, maybe that purposefully looks like this, so it looks like these, you better be ready, because if you split this into 2, okay, you're kind of not in good shape. All right. What else on the quiz preview in particular before I get to start getting picky on things? Or are we ready for me to go to the extra questions already? Because I'm good with that too. People watching this at home later are like, somebody say something. Do we think we're good on everything else?
2 or 6.
All right, and this is one I will also be able to give you a little insight into. This will be happening more. Basically, on most quizzes that we have moving forward, there's going to be at least one question like this where it's asking you to explain, you know, what's going on instead of necessarily just showing me on the paper. So we're just putting the first step in words. If you were doing this problem, what do I have to do first? Absolutely. Okay. Multiply both sides by 4. And yes, you've got to put both sides, because if you just put multiply by 4, I'm going to put a question mark on there. I'm going to be like, am I multiplying x plus 7 by 4? Am I just multiplying 4 by 4? What am I multiplying? So be specific in what you're doing. And it's not just show me the math work over here. I want you to be able to do it as though you were having to explain it to me verbally. Because that's the way standardized testing is starting to move. It's going to start moving towards you explaining things instead of just doing them. So we're going to start working that a little bit more. I was going to say, a lot of stuff at the bottom should look like review to you. I hope at this point. I hope. Any other issues before I start? Oh, look out, I got issues all of a sudden. 11. Which one?
Number 9.
Okay, 9 and 11. All right, let's move up here a little. We can get them both on the screen here. Now 9, I'm going to sort of treat the same way that I treated the first problem that we did with the absolute value on the other side. Before I can get to all of this other stuff, I've got to do things one part at a time. So here's the way I'm looking at number 9. Okay, my first job is I have to get that fraction that has x in itself by itself alone. So before I multiply by -3, okay, Some of you are like, well, couldn't I multiply by -3 right away? You could, but here's what's going to happen to most of you if you do. You're going to multiply here by -3 and here. You're going to cancel these out. You're going to multiply this by -3, and you're going to leave the -8 alone, which in this case would be a problem, because you'd also have to multiply this by -3 if you did that first, which is why we are going to avoid that problem altogether by isolating our fractional term first. Because now, by doing that, oops, attention to detail, now I can multiply both sides by -3, and it's going to keep me out of trouble because there's only one term on each side. At this point, the only thing that could get me into trouble would be if I were to distribute the -3, but remember, this is one term. That -3's whole job is just to wipe that out. Always deal with what's furthest away from your variable first, then start removing things that are closer. The -8 was furthest away, we dealt with it. The divide by 3 is furthest away, we dealt with it. Now this +7's the furthest away, and we're dealing with it. And then we just divide by -3, and fractions are okay. Just because we get a fractional answer for an equation doesn't mean it's wrong. All right, now our old nemesis from the first quiz. Solving for variables. Oh, there's 2 of them. Oh, gracious. You're like, okay. A little bit of a twist here, though, because they're on opposite sides of the equals. You're like, well, you know, what can I do here? Because if I divide by 4, I'm still going to have p's. If I divide by 4p, I eliminate both p's. So what am I supposed to do? Well, let's get all the p's together on one side. Let's see what happens. Because then this should eerily start to look similar to something we've done before. I have 2 terms on the same side with the same variable that I'm trying to solve for. What do these 2 terms have in common? Okay, p. Now some of you may see a little more than that. Some of you may see 2p. So I'll explain how I can deal with it both ways. If I see they both have p, especially since that's what I'm solving for, I'd factor that p out and I'd say, okay, p times 4 is 4p. P times -2r, bless you, would be -2pr. And notice what happens. Now I only have 1p. Even better than that, all the stuff that's on the side with it's just being multiplied by it. So I can divide by that whole group at once and get to a solution. Now, I would hope at this point some of you would look at that and say, well, wait a minute, though. Can't I take a 2 out of all of those? Yeah. Because remember, these are bonded, but if I can take something out of everything, I could do it. I would accept this answer tomorrow. But if some of you decided you were going to take it a step further and you said, okay, I can take a 2 out of each of these, and you wrote it like this, that's actually a better answer. But if you didn't, again, my biggest thing right now is when you're dealing with a variable term, can you isolate it? Can you get everything else away? The little detail stuff with reducing we can deal with as we go. But that's going to be our biggest thing on this. And if you took the 2 out with it originally, you're going to end up with this answer anyway. So it works out either way. But just make sure if you see more than that variable that you're solving for more than once, get them together. And if one disappears, great. And if not, you got to do a little factoring. You're like, all right. What else, what else, what else? So like I said, I got more ready to go whenever.
For about 10, just like do like the first couple steps?
Sure. Now here, another different issue. You're like, well, I'm dividing by x. Oh, I got two x's here. What the heck? Okay. Normally I'd look at that and I'd say, okay, I don't like fractions. So let's multiply by x. You're like, okay, not quite sure what purpose this is serving, but okay, so oops, plus x equals 8x. You're like, well, I still have all my x's here. What now what? Well, let's get them all to one side. So let's say I bring them over here, since I already have just x over here anyway. And then it becomes clear to us, oh, 8x minus x is 7x. I just went from 2x's to only having 1. This is great. Because now I'm trying to solve for x, so all I have to do is divide by the number that's with it. And I've solved for x. So you notice here, just because I see multiple x's or multiple anything that I'm solving for in a problem doesn't mean that I necessarily am going to have to factor every time. But it's one of my tools in the toolbox that I can use if I have to. Any other specific ones on here?
How about tall?
Okay, now, here's one that I would suggest again. Verbal to math. Because some of you just look at it and you randomly want to start throwing numbers down on the paper and not really paying attention to what goes where and hope it sticks. So when I'm doing this, I look and I read it. Okay, Netflix is charging $7.95 a month plus 50 cents per movie download. Write an equation that describes the relation between downloads and cost. Okay, so I look and I say, okay, so if I get my Netflix subscription, how's this work? Well, they charge me a fee, and then they charge me for downloads, and that equals what it costs me at the end. Okay, so I verbalize it first. Once I do that, now I can start sticking numbers and variables in places. So all right, they charge a fee of $7.95 a month. So whether I download anything or not, they're charging me $7.95. Gotcha. Then they're going to charge me 50 cents a download, but the fee is the same no matter how many downloads I do. The downloads, that depends, man. If I download a lot of movies, this could cost quite a bit. So they tell me downloads are going to be represented by D. So 50 cents per download equals how much money I'm going to spend, because it tells me everything else. Nothing to solve this time. Sometime I may tell you what the cost is and make you figure out how many downloads or something it is. I'm just saying. But otherwise, that's all I'm doing here. And yes, it matters where you put the D. I don't want to get charged $7.95 per download. Gracious, that would be expensive. So that's what we're on the lookout for with those. Other issues for I change gears.